Okay, so now we were discussing the biological process in filtration, is it? Now the next one is electrostatic adhesion. So electrostatic adhesion causes material close enough to grains of filter media to be adsorbed onto them. It is very simple, is it? Because of electrostatic adhesion, the very small particles which is very close to the filter media, when the water is flowing through the filter media, it is adsorbed onto them. The next one is impaction. So heavy particles are smeared with the slime on which other particles are collected by inertial impaction. So smeared means, you know, is it അത് ഇങ്ങനെ വഴുകി താഴേക്ക് ഒഴുകുകയാണ് അല്ലേ? വഴുകി ആ സ്ലൈം ലെയറിൻ്റെ പുറത്തൂടെ വഴുകി ഇങ്ങനെ ഇതൊക്കെ താഴോട്ട് മൂവ് ചെയ്യുമ്പോൾ what will happen? It will be collected by this sticky material, and because of the inertial impaction it is stick to that particular layer. That is the impaction. Now the next one is electrolytic action. The process of filtration may be explained by the ionic theory, where two opposite charges are found to be neutralizing each other and the charges when they come in contact. And we know that the sign grains of the filter media are of positive charge and the colloidal particles are of negative charge. So when these two particles, when these two ions are coming in contact, they neutralize each other. The opposite polarity, because of the opposite polarity, they neutralize each other, and as a result, the flocculation can occur within the interstice. Interstice means within the small pore spaces of the sun grains. It is not this outer surface, it is the small, very small particle, very small water molecules within the sand grains and these media and the particles. So then these particles will flocculate because now it is not having any charge and it is undergoing sedimentation within the media. That is the electrolytic action. And then so because of all these processes, what is happening? The physical and chemical adsorption through bonding and chemical interaction hold the particles within the filter medium. That means because of the chemical and as well as the physical bonding, the particles which is settled there or which is adsorbed to the surface of the media, it is holding in the filter medium itself. And but we know that the sand particles are now having already having positive charges. Now because of the sedimentation or the deposits, now it loses its positive charge. But we want to regain its polarity, is it? So what you have to do, you have to clean the media at regular intervals. You have to clean the media at regular intervals. So that is termed as backwashing or cleaning of the media. And this process is based on the type of the filter it is changing, how it is washing, or whether it is backwashing or whether it is cleaning of the media. So that we will discuss later. Now coming to the classification of filters. The filters are mainly classified into two types, that is slow sand filter and rapid sand filter. Both these slow sand filter and rapid sand filter are working under the principle gravity flow, and the third filter, that is pressure filter, that is working on pressure, that is working under pressure, that is under the flow is under pressure. That is based on the rate of filtration. That is based on the rate of filtration, these three classifications: slow sand filter, rapid sand filter and pressure filter. Now these three filters, it is considered as different based on 4 parameters of its working. Based on 4 parameters of its functioning, The first one is the head required for filtration. The head required for filtration. Second one is the rate of filtration. And third one is the composition of filter media. Composition of filter media. And fourth one is the method of cleaning or the frequency of cleaning of the filter media. Now these 3-4 parameters are the design criteria for the filtration or filter beds. Okay. Now what do you mean by media? What is the medium we are using here for filtration? We all know that the filter media, that is the medium through which the water is passing, that is nothing but the sand, is it? But this sand should have certain properties. The ideal filter medium should have a size and be of such material that it will provide satisfactory effluent, retain a maximum quantity of solids, and be readily cleaned with a minimum of wash water. So this is the fundamental prerequisite for a medium through which the water can be filtered. And considering these two things, that means the medium should have a size and be of such material that it will provide satisfactory effluent. And again, it should retain a maximum quantity of solids within the media, within the box itself, is it? Within the container. And it should be cleaned with a minimum quantity of wash water. And satisfying all these prerequisites, the commonly used filter materials are, first one is sand. So sand is the first and foremost filter media used all over the world. Since sand has got these two prerequisites. Now another filter media, it is used in some international countries or some developed countries where this anthracite, that is not a natural material, it is a byproduct, it is an industrial product, and where it is available, this anthracite is available in certain countries, in certain plants they are using this because it is available there. And anthracite, as we are considering, it is we have to import it. It is a foreign material. Then it is a lightweight material also. So it has got certain advantages as well as disadvantages that we will discuss later. Now the third one is the garnet sand. Garnet sand is nothing but the green sand. And green sand again, it has got the good qualities of all the prerequisites, but it is very costly. And then we all know that we usually use certain other locally available materials also we use, is it? That we will discuss again, the locally available materials. That is the crushed coconut shells, is it? You all remember many of the students are doing some projects based on the crushed coconut shells. A different type of such materials are there, but the commonly adopted media is sand. And now what are then again, this sand should have some properties. Here it is mentioned that the sand should have a free from clay. That means the sand should be free from clay, silt, loam, then suspended matter and other organic matter. Usually the sand which we collect from the rivers are being used as the media, since it is free from clay and silt or loam. Again, suspended or impurities matters are not there. So we used to collect it from the rivers. Now the second one is it should be fairly uniform and of the effective size 0.2 to 0.3 mm for slow sand filters and 0.45 to 0.7 mm for rapid sand filters. So that means effective size, you know, it is the D10, is it? The D10 size, that is 10% of the particles, 10% of that, what is that, this sand will pass through 0.2 to 0.3 mm of the seal, is it? 0.2 to 0.3 mm size seal, that is D10, is it? That is the effective size. Then for rapid sand filters, it should be 0.45 to 0.7 mm. That means little bit bigger size or larger size than the rapid sand filters. Sorry, than the slow sand filters. Okay. Now the uniformity coefficient. So the uniformity coefficient for slow sand filters, that sand media should be 3 to 5, and for rapid sand filters, it should not be less than 1.3. nor more than 1.7 in rapid sand filters. That means the uniformity coefficient must be between 1.3 to 1.7. So what do you mean by uniformity coefficient? You all know it is ratio of D60 by D10. Is it 60% of the particles will pass through a particular size, and 10% will particle will pass through the other particular size, and when you take the ratio, it should be between 1.3 to 1.7. That is your uniformity coefficient, is it? Then next one is, it shall be hard and resistant quartz. So that means the sand media must be hard. It should not break easily, and it should be resistant quartz. You know it is quartz, sand. Then ignition loss should not exceed 0.7%. It means when we burn the sand, it should not lose its weight by 0.7%. Usually the sand, when we burn it, it will not lose its weight, or it will not change its properties, is it? So sand is, again, it satisfies the prerequisites. Then next one is, a soluble fraction in hydrochloric acid shall not exceed 5% by weight. That is, when we dissolve the sand in hydrochloric acid, or if you put the sand in hydrochloric acid, it should not lose its weight by 5%. That means it should not dissolve in hydrochloric acid, is it? That is the next thing. Then next one is, the specific gravity shall be in the range between 2.55 to 2.65, is it? We know it is the specific gravity of the discrete particles, that is 2.65, and that means here it is giving a range between 2.55 to 2.65. Now next one is, the wearing loss shall not exceed 3%. Wearing loss means when we handle the sand, when we deposit it in the sand bed or in the filter box, and when we took it back for washing, it should not lose its weight or it should not waste more than 3%. So wearing loss, it should not exceed 3%. Now coming to so these are the characteristics of the sand which we select for the filter media. Okay. Now coming to the anthracite. So anthracite is a coal. Anthracite coal, it is actually anthracite coal. It's a dense, low ash, low volatile, high carbon content coal. High carbon content coal with a high calorific value and a specific gravity of about 1.4. About 1.4. And its low density compared with the sand allows it to be used in a coarse size in the top layer of a sand filter, and makes possible the practice of coarse to fine filtration in gravity filter. It is not recommended conventionally as it is very costly and not available in our country. That means this anthracite coal, which is of low specific gravity. That means its weight, it will float in the